Good evening, Year 13s. In this video here we're talking about the chain rule, and I've got a couple of definitions here. One definition from the textbook and another definition that's from your formula sheet. I actually prefer the formula sheet one because it talks about y as being a function of u and u as being a function of x. And so when we're looking for the derivative of y with respect to x, we have to find the derivative of y with respect to u, and then separately the derivative of u with respect to x, and multiply those derivatives together. But very informally you can see here that your change in u's cancel out, and all you're left with is dy by dx anyway. So that's the formula I prefer, but you really have to get used to notation yourself. But I find with the chain rule, the best way to explain it is really to go through an example and apply it in that situation. So let's look at our first example here, where we've got h of x equals 1 over x squared plus 4. The first thing I'm going to do here is write it as h of x equals x squared plus 4 to the power of negative 1. Simply because I can apply rules about powers here more easily rather than have it as a fraction. Now what we're going to do here, or what we have to recognise, is that in the form it's in at the moment, I can't differentiate it because I wouldn't know what to do with this power here. And so what the chain rule says is, in that case, make a substitution. So write it in terms of another letter. So I'm going to write it as u to the power of negative 1, where u is the stuff inside of the brackets. So just to explain what's happened here, is I've taken this stuff and I've brought it over here, because what I've said essentially is that this whole bracket is now equal to u. And so instead of having the bracket to the power of negative 1, I've got just u to the power of negative 1. Okay? And so when we're finding, when we're working towards our derivative, the chain rule says that dy by dx equals dy by du times du by dx. So we really need to work out these bits separately before we substitute them in. So h of x is in essence my y, and so if we're going to find dy by du, that's going to be this function here. So let's do that first. So dy by du is going to be negative u to the power of negative 2. So I'm just applying my normal differentiation rules to come up with that. There's no trick or magic there, that's just our normal differentiation rules. So with the next one, we've got du, we're going to work out du by dx, and once again apply our normal differentiation rules. So I've just taken this expression and differentiated it. So now I'm going to write out the formula. So dy by dx equals dy by du times du by dx. And so here's our dy by du, that's going to go into there. Here's our du by dx, that's going to go into there. So our derivative, so our h dash of x is going to be negative u to the negative 2 times 2x. So now I can substitute back in for u, and so that will be negative u, negative x squared plus 4 to the negative 2 times 2x. Now as far as NCEA is concerned, that's far enough, but you could write that a bit more elegantly if we use fractions. So we could write this, for instance, as negative 2x over x squared plus 4, and that's just a little bit tidier than what we have above. So this here is, for NCEA, and this here is because we are mathematicians. Okay. Alright, now that process actually becomes very robotic after a while, and so in the next question I'm going to show it how we can do that same process, but really in a much faster manner. So let's look at this example here. We'll just move it along a little bit. Okay, so what I'm going to do here is just go straight to writing dy by dx, and I'm going to apply this power to this whole bracket with differentiation. So I'm just going to write 4 bracket and then everything in the bracket as it is, and then reduce the power down to 3. So all I've done there is I've just treated this as a single differentiation thing, and then I'm going to multiply it by the derivative of everything inside the bracket, and so that's going to be 3x squared minus 8x, and that's it. So I've just jumped straight to the answer there using the chain rule or the composite rule. So you can see here the difference between the amount of working that I've shown. This is, way too much really. You can go straight from here to here because all you're doing is differentiating the bracket first and then differentiating what's inside the bracket and multiplying them together. You can kind of think of this a little bit like your differentiation bed mass. Okay, so once you've got a handle on that process through working on exercise 15.02, you could maybe start to think a little bit about why this chain rule works. But it's one of those chicken and egg situations where I think it's better to practice the skill first and then let the understanding come later. So 15.02, get started on that please.